Alright, this is example number 1 on the general structures section 1 of the Kaplan AEC architecture study guide or test or whatever you want to call it. Anyways, question number 1 says find the resultant of the two forces shown. And in his solution he seems to take the lines of action and does some crazy stuff that I'm not horribly proud of. He says from their intersection lay off the two forces to scale, which I would never scale these things. I think it's a horribly stupid idea. What you do is you put the two ends of the vectors together, with these force vectors as you might call them. So you have the, hold on, there we go. You have this 500-pound force right here. Let's go 500 pounds. And that's at this angle, which 3, 4, 5 triangle. And then you also have this one coming off. That's 13, 12, and 5. So this is a 1,300-pound force and a 500-pound force, and they're both at that. So you're adding them together. And the main thing to remember in this is the parallelogram rule. These are going to make a parallelogram. If you brought this down to the end, you can kind of take this one. You have to have a starting point. Unless that's your starting point, and then you can either take this one and then add that one. So you would take that and put it down here to make it look like this, or you could start with this one and then add this one, and so you'd put the tail of this vector and put it down here. Either way you do it, it comes out to this point. So see how it makes a parallelogram, and your resultant's going to end up coming at right there. So this is going to be your resultant. So the question is, what is that resultant? And it looks like what he does is he uses kind of graph paper and he scales it, which I would say is dumb. 99% of the time you're not going to get any engineers ever going to scale a force, and you'll see that coming up soon. But anyways, so this is a huge mess and about impossible to see. So what you want to do is when you have vectors and you're adding together, or forces really, let's kind of start over again. You have this one. Ooh, shoot. And that's 1,300 pounds. And it's at 12, 5, 13. What you want to do is you want to break it into components. Essentially X and Y components. So if we call this right here, let's call this force A. You want to break it into components, and what I mean is X and Y components. So realistically I will say FA means force of A in the Y direction equals, well, see how this is 13 and A equals 1,300 pounds. So this will equal 500 pounds. If you get that, I'm sure you understand what I'm talking about. That's what it does. Anyways, so the force in A is 500 pounds. And then the force of AX is 1,200 pounds. And I hope that makes sense. I'm sure it does. If it doesn't, just we can go over a bunch of examples and you'll get it in the next couple of examples. So anyways, you want to do that. And what you can essentially do is add all the forces in the X direction and then all the forces in the Y direction, and you will get a resultant force which will equal FA plus FB. We'll call this FB. So there's FA. Then you want to have FB as well. There's FB. We're going to call it FB. And E equals 500 pounds. That's right, yeah. And then its orientation is like so. It makes a 3, 4, 5 triangle. And so if you do the same type of thing, you say, oh, okay, here's your, I guess you should really do this. This is your y-axis, and this is your x-axis. I'll say this is your plus axis, and this would be obviously negative side of x, and this would be negative side of y. So you have, let's go back here. That's going positive x, this is going positive y. So you have to go positive x 12, or 1,200 pounds, and then you have to go positive 500 pounds to get there. And same thought, you go positive 300 pounds, or since 5 equals 500 pounds, 3 equals 300 pounds, 4 equals 400 pounds. So I would say force in the bx direction, since you're going in the x direction, and it's positive x direction, since it's going to the right, equals 300 pounds. And then you have your force of b in the y direction equals, since it's going down, you have negative 400 pounds. Alright, that is that. So, let's see, I'm going to move down a little bit. Okay, there you can see everything. So now what you want to do is you want to add your components, and that will give you a final, your final vector, or your final force in the direction it needs to be in. Alright, we have what? Let's do FAX equals FBX equals, then over here we're going to have FAY equals, and then FBY equals. Go over here, FAX equaled 1,200 pounds, positive 1,200 pounds. FBX, which was right there, equals 300 pounds. That's not a negative. And you go over here, oh, I guess let's add that together. So I would call your force R would be resultant, and the x direction equals 1,500 pounds. And you go over here, and FAY was 500 lbs, and then FBY was negative. Well, we didn't put negative over here. Let's do that. Wait, no, that's not right. Cancel that. We called it negative just because it's going down, but you don't really have to call it negative since you're showing it. It's kind of, I always would call it negative, just so you know it's going down, but we'll get there. In essence, it's negative 400 pounds, because it's in the opposite direction that is. So I would call it negative since it's going down. Makes it clear. Oop. And that is 100 pounds. And this is going to be the resultant force, and I call it FR, in the y direction equals 100 pounds. Now you used to say, okay, well, I got that. What does that get me? Well, you go over here, and there's your starting point. And you want to go 1,500 over in this direction, and then you want to go 100 up. So this is 1,500 pounds down here, LBS, and 100 pounds. And this is your FRX equals that, and this is your FRY. Fry. And there is your resultant. And that's what your resultant is. Your resultant is, if you remember, there's a lot of ways you can do this, but the easiest way is Pythagorean theorem, which states, I don't remember if you know this, but it is, shoot, what is Pythagorean theorem? It is, let's say, a squared plus b squared equals c squared, something like that. Anyways, what it is this equals that, this squared times this squared, and the square root of those two. Anyways, let's call this h. Let's call it fr. There we go. In essence, fr is going to equal the square root of frx squared plus fry squared. And I hope that makes sense to you. So, because this side squared equals this side squared plus this side squared, but you just take the square root of that square and you put that over here. It's algebra. I'm sure you remember it. Anyways, and that would be, what is 1500 squared? Squared plus 100 squared, and that to the 1/2 power will give you FR. And then I get out my trusty calculator. And this is just taking the square root of something. I don't remember. If you know that, that's what I do in my calculator. So the square root of 1500 squared plus 100 squared, and then you take the square root of that, and that it leaves you with 1005.03.3 blah 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 pounds. Let's see if that's the right answer. And that's exactly what he got. He said they scale the value of the resultant as 1,503 pounds, which is exactly what we got, except this is going to be your exact thing. I don't trust scaling. This is your exact answer. So, like he said, what is the resultance of, this one plus this one? And as he said, we can make a parallelogram. And that's going to be your answer is going to be right there. This, we did it mathematically. You're never going to take something and make a parallelogram out of it in engineering. That's a dummy check. You can say, oh, okay, does it make sense? Oh, yeah, it makes sense. This one has this and that one's going up, and this one's going over. Okay, and this one's going down and over. So if I add those together, they're about right here. Okay, yeah, that's my resultant. That's the only way you're going to do it, but you're not going to do this. You're not going to use the parallelogram theory in actual practice because you're going to screw yourself up. But that is the example 1, and I'll go into a little bit more. This is my first time, so I hope it's all right.